to another segment on Wisdom Window. I hope you guys are doing great, and it's so lovely to have you here with me today. Did you know that you can use household items to solve math problems? Well, I found a couple different items that I'd like to show you. My first item is this little tiny magazine. It's a wedding magazine that I got when I went to an expo. And then I have another item. It's like this. This is a notepad, and it's one of the many that I write lists on, or just extra things to remind myself. Did you know that these two items have something in common? Can you guess what that might be? And no, it's not just because they're made out of paper. I want you to think about something that we've learned. What did we learn in our last segment? Yeah, so we learned about same perimeter but a different area. Now, do you think that these have the same perimeter? Why or why not? Do you think they have the same area? Why or why not? Well, today we're going to use these to help us in better understanding our new topic, which is the same area but a different perimeter. Pretty cool, right? Can you believe that these are going to help us learn that? Well, we're going to use these in just a few minutes to figure out how these really have the same area but a different perimeter. Before we do that, we need to focus on talking like mathematicians. And we do that by reviewing our vocabulary and figuring out some ways that we can talk like mathematicians using this vocabulary. So, to review, we've learned about area. And area is the inside of a figure. And we find area by multiplying the length times the width. And by doing that, we find the space in between. And then a square unit, we learned that that is the individual squares, like in a grid, that help us measure something. And those square units can be a bunch of different sizes. When we talked about standard units, customary metric units, we learned that we can have something as small as an inch or something as large as a yard. So it depends on what square units you use to measure an object. Because if it's a bigger object, you're going to want to use a bigger square unit. Whereas a smaller figure, you're going to want to use a smaller square unit. And then also a couple segments ago, we learned about our customary and metric units. We learned that customary units are used inside the United States, and they cover inches, feet, yards, and miles. And then we have something called the metric units. And that's something that is used in Europe and around the world. And they cover meters, centimeters, and kilometers. And that's how they measure stuff. And then we also learned about the distributive property. And that helped us measure our garden last time, where we had a garden and we wanted to split our garden to vegetables and then some fruit. And we were able to use a distributive property to have the same length and then multiply two different widths to find the area of the entire figure, but also to know the area of the fruit side of the garden and then the vegetable side of the garden. It's a pretty amazing tool. And then we also learned about irregular shapes, and now that was a challenge. But you guys rose from the challenge and you guys learned so much. And I'm so proud of you for taking on that challenge that we had. And then we reviewed perimeter again because we were struggling between the perimeter and area and how to distinguish those. And so we reviewed that the perimeter is the outside of a shape, or our fence, and that we add all the sides of a shape to find the perimeter. And I also realized that I have a little clue for you guys. If you cannot remember if we're going to be adding or multiplying for a perimeter, just think of this. Perimeter starts with a P, and so does plus. So perimeter plus. So for perimeter, we add. Okay, so that's a little trick for you to use. And then just to remember that area, we're multiplying the length and the width. Super important to know the difference between these two because they're going to be coming up for the next couple lessons. Alright, and now to use these two different household items to help us understand how to find the same area but different perimeter. Can you believe that these two items have the same area but a different perimeter? Kind of cool. Do you want to see how? Well, on the backhand side of both of these objects, I was able to lay out a grid to measure them. Isn't that cool? You can do this with household items around your house too. Pretty cool. I just printed out a piece of graph paper, or if you have a piece of graph paper at home, or if you make your own, you can get a little creative with that too and make your boxes smaller or bigger. So here I measured with inches. So my square units are in inches today. And so now let's find out what this looks like in math. So how can we use these two items to help us solve for area and perimeter? All right, let's go try it out. And so now I've converted these two objects with the graphs I've used onto my whiteboard. And we're going to use my whiteboard to help us figure out if these two objects that I had in my house really have the same area and a different perimeter. Let's figure that out. So the first thing I wanted to figure out was if they have the same area. And so by doing that, I'm going to write my area formula. And my area formula is A, or area, equals L, or the length, times W, or the width. And I'm just going to write that now on both of these figures. Okay, and so I need to look at this figure first, which is also my notepad, and we're going to find the length and the width. So here I have counted 9 square units on my length side of my object. So I'm going to write 9 inches. And then on my width side, I have 4 boxes, or 4 square units. So I'm going to write 4 inches. And now I need to find my area. So my area equals my length of 9 times my width of 4. And how do you solve that? What is 9 times 4? And remember, if you're having a little bit of a hard time trying to figure out this multiplication problem really fast, you can also do it like so. You can do 9 times 2, because 2 is half of 4, and that's kind of breaking down our problem. So we can do 9 times 2, and we know that 9 times 2 is 18. But now we need to do 9 times 2 again, because we need to multiply it a total of 4 times, and that's what 2 times 2 is. And so if we multiply 9 times 2 again, we get 18. And so we're just going to add those two up. What is 18 plus 18? Well, I know that 8 plus 8 is 16. So I'm going to write a 6, and then I carry the 1. So I have 1, 2, 3. So my area for the notepad is 36 square inches. Super important to remember that when we write an answer for area that we use the term square inches, because we are multiplying. And now we need to find the area of our magazine. And here I have labeled 6 in my length, so 6 inches. And then I have 6 square units up on top here for my width, so I have 6 inches there. And so now I'm going to solve using my area formula. So I have A, or area, equals the length of 6 right here, and then multiplied by the width of 6. And so area equals 6 times 6. And 6 times 6 is, can you tell me what 6 times 6 is? Good, 36. I'm glad you're practicing those multiplication problems. All right, so we have area equals 36. When we write the answer for area, what am I going to put in there? 36 elephants? 36 bananas? 36 trees? No, we're gonna write 36 square and then our units, and our units are inches. And now what do you notice here? Are our areas the same? We have an area of 36 square inches for this figure, and then we have an area of 36 square inches for this figure. So do these two items have the same area? They do. They have the same area. Isn't that crazy? And now for the final truth, we gotta find out if these two have the same or a different perimeter. But we're really hoping that they have a different perimeter. And how do we find perimeter? I forgot. How do we find perimeter? You might want to look at our vocabulary wall just in case you forgot. So how do we solve for perimeter? Awesome. I'm glad you remembered. So if we look over here, we're adding. We're going to find the measurement around a figure. So we're going to use that fence line. Here, 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 and here. As well as here, 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 and here. We're going to do that whole entire fence line and we're going to add them. So I'm going to write my formula first. I have P for perimeter equals a side plus a side plus a side plus a side. Because I have 4 sides. If there's more than 4 sides, then you'd probably add a couple more S's. Alright, and then so I have a length, or my first side is 9, so I'm going to write 9, plus my second side is a 4, and now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 inches on this side, so I'm going to write a 9. Then we have 1, 2, 3, and 4 on this side, 4 inches. So now all we need to do is add up all of these numbers to find our perimeter. So first I'm going to add 9 plus 4. What is 9 plus 4? Good, 13. And now we're going to add our other side. What is 9 plus 4 again? Good, 13. Okay, and then now we just need to add these two 13s together to find our total perimeter. And 13 plus 13 is 36. 36? Are you sure? How about we add this a little bit slower? So we have 3 plus 3, and that equals 6. And then we have 1 plus 1 is 2. There we go. All right, so we have 26, and that is our answer. Am I done with that answer? We have to add our units. And since we did not multiply, we are not going to write square units. We're going to write units. So my units here are inches, so I'm going to write that my perimeter equals 26 inches. All right, and now the moment of truth. We need to find the perimeter of this figure to figure out if these two objects have a different perimeter but the same area. All right, it's getting exciting. Let's do it. All right, so we have our perimeter formula. Just going to draw a line here. My perimeter equals a side plus a side plus a side plus a side. So you have 4 sides that we're adding. And now let's see, my first side is 6 units. And then my other side is 6 units. And then let's see, we have 1, 2, 3, 4, 5, and 6 units. On our last side, we have 1, 2, 3, 4, 5, and 6 units. So now we need to add all of these units together to find the perimeter or our fence line of our figure, or the magazine. Or the magazine. All right, so now we have 6 plus 6. And what is 6 plus 6? Nice. 6 plus 6 is 12. And now we're going to add 6 plus 6 again. Good. 12. And now we need to add 12 plus 12. Yep, exactly. And 12 plus 12 is 24. 4. So our perimeter equals 24. Is my answer done? No. I'm glad you caught on to that. We're going to write units, and our units are still inches. Would I write that my perimeter is 24 square units or square inches? Why not? Exactly. We only write square units or square inches, square feet, square centimeters if we're talking about area, if we're solving by multiplying. So that's really good that you picked up on that. All right, and so now we need to find out, is it true that these two figures have the same area but a different perimeter? Let's see. So we know that they have the same area. They both have an area of 36 square inches. And then let's see their perimeter. The perimeter of my notepad is 26 inches. Okay, and then my perimeter of my magazine is 24 inches. So it's true that these two objects have the same area but a different perimeter. Isn't that crazy? Now, you can continue to work on this and find objects around your house. You can measure them with a grid or maybe even a ruler and see if you can find items around your house that also have the same area but a different perimeter. It's a pretty fun activity. All right, and now since we've had some practice to really understand how to find the same area but a different perimeter, let's go to our workbook page and we're going to practice some more problems. All right, let's go. So now I have grabbed my 14-9 workbook page, and here it's talking about the same area and different perimeter. So this is just going to give us some extra practice in solving problems like these. And so for these problems, I've noticed that there isn't a lot of space over here to show my work. So I grabbed a scratch piece of paper, and I recommend that for you to grab that as well. You can grab any type of paper. You can grab lined paper, any type of scratch paper. This is just what I had nearby, so that's what I'm going to use. And so now I'm going to go over problems 1 and 4 with you, and I'm going to model how to do number 1, so that way when we get to number 4, we can work on that together. So for number 1, let's read the directions. It says, for 1 through 9, write yes if the two rectangles have the same area and no if they do not. Okay, so that's my first thing. So we need to write yes or no if they have the same area or not. And then if they have the same area, we need to tell which one has the smaller perimeter. Okay, so let's work on that first problem using our first step. So for number 1, we have a figure A and a figure B. Figure A has a length of 8 and a width of 3. And figure B has a length of 6 and a width of 4. So first, in order to solve our first step to the problem, we're going to need to find the area. So let's find the area of figure A first. Right, figure A. And so to solve for area, we need to write our area formula, and that is A, or area, equals the length times the width. And for figure A, we discussed that our length is 8, so I'm going to write 8, times our width of 3. So now to find the area, we just need to multiply 8 times 3. And what is 8 times 3? Good, 24. Okay, is that all? Is that all I need to write for my area answer? I can just leave it as 24? Nope, not at all. We're going to write 24 square units. And I decided to just write units because this figure or this figure doesn't signify if we're talking about inches, foot, yards, miles, centimeters, you name it. So I'm just going to write units. So that's my area for figure A. And now I need to find the area for figure B. And so I'm going to write my area formula again. I have area equals the length times the width. Now I'm just going to plug my information in. So I have a length of 6 times a width of 4. So now I have to multiply 6 times 4. And what is 6 times 4? Well, like I did earlier, I know that I can split 4 into 2. So if I don't know how to multiply 6 times 4, I can do 6 times 2 and then add those together, the 6 times 2. 6 times 2 is 12, and 6 times 2 is 12. If I add those together, I'll get the same thing as if I were to multiply 6 times 4. So 6 times 4 is 24. And then I want to make sure that I write square units because we are multiplying to find our area. All right, and now I have to answer my question. So my direction said write yes if the two rectangles have the same area and no if they do not. So now I look here at my area, or my figure A, and then my figure B answer. And they're both 24 square units. So on my line, I'm going to write yes, because they have the same area. And now for part 2 of the question, it asks me if they have the same area to tell which of them has a smaller perimeter. All right, so now we have a second step to this problem. So now we need to find the perimeter. And how do we find that perimeter again? Exactly. So let's see. So my perimeter equals, we're going to add up all the sides. And in this case, both of my figures have 4 sides. So I'm just going to write side plus side plus side plus side. And now I'm going to plug it in. For figure A, I have a perimeter equals a side, which is 8, plus another side, which is 3. And now we're going to use our knowledge of rectangles. And we know that our length must be parallel to our other length, and our width must be also parallel to our other width. So in knowing so, I know that since this side is 8, my other length side is also going to be 8. I'm going to write that there. So I have 8 plus 3 plus 8. And now I have one more side, and so now I know that this width is parallel to this side. So 3 would be the width of this side as well. So we have 8 plus 3 plus 8 plus 3. And now we're just going to add those together. So 8 plus 3 is 8, 9, 10, 11. 11. Then we're going to add it to 8 plus 3 again. And 8 plus 3 is 11. So 11 plus 11 equals 22. But 22 what? I can't just leave my answer like that. Good. I'm going to write 22 units because we don't have an indicator of it being inches, centimeters, or etc. All right, so that is my answer for perimeter. And now we need to find the perimeter of figure B. So I'm going to write my formula really quick so that way I'm staying on track. So now I'm going to look at my figure B, and I notice that the length here is 6. So my first side is going to be 6. My second side has a width of 4. And now, since this is also a rectangle, we know that these two parallel sides are going to measure the same size, and so are these. So, since this side is 6, so is this side. And since this side is 4, this one's going to be 4 as well. And so we have 6 plus 4 plus 6 plus 4. Remember, if you're having a hard time keeping track of which numbers you have written down, after you have written a number down in your problem, you can also just cross it out. And that way you can keep track of what you have written just in case it gets a little confusing. All right, and now we're just going to add. So 6 plus 4 is 6, 7, 8, 9, 10. 10 plus 6 plus 4, which is also 10. All right, and then we know that 10 plus 10 is 20. So my perimeter equals 20, and then don't forget units. Okay, so now let's see. It says, which one has the smaller perimeter? Well, let's see, we have an answer of 22 units and an answer of 20 units. All right, well, I think we know our answer. Figure B is going to have the smaller perimeter. So to show my work, I'm just going to write yes and then figure B. All right, and now we're ready for number 4. Let's work on that one together. All right, so let's look back at our directions. We have that yellow part, which is our step 1 of the problem that we need to solve. So let's see. Can you read me the directions, the yellow part? Okay, so we're going to need to find the area of both of the figures, right? Can you walk me through that? Okay, good. So we're going to write our area formula first. Area equals the length times the width. Now what do we do? All right, so we have area, and so we know our length. Where did you find the length at? Good, right here. So we have a length of A. Good, I'm glad you reminded me that we're on figure G. Okay, and then our width is what? 5. Nice job. So now we need to multiply 8 times 5. Can you tell me what 8 times 5 is? Good. 40. And then how did we solve this answer? Or how did we finish this answer? This is missing something. Good. When we multiply, we're going to write our answer in square units. Okay, and now what's our next step? Exactly. We need to find the area of the next figure, or figure H. Okay, what's our first step? Yep. Area equals length times the width. Now let's plug it in. What is our length of figure H? Good. 2, right here. And then what is our width of that figure? Good. 20. So now we have to multiply 2 times 20. What is 2 times 20? Good. 40. And then are we done? Exactly. We cannot forget our square units. Okay, so now we found our square units. Now we have to answer our first question. So, do these two rectangles have the same area? Yes, they do. So I'm going to write yes on my line. Would you do that as well? All right, and then what is our second step? What is our next part of the problem? Exactly, we need to find the perimeter. So I'm going to write down here for figure G, and then for figure H. Okay, so remember the perimeter is all the sides added up. So we have 4 sides, so I'm just going to write side plus side plus side plus side. All right, can you tell me what the first side is? Yep, it's 8. And what's my second side? 5. And what is this side over here? Do you remember how to find that? Exactly, it's 8. And we did that, and we know that because we have a knowledge of rectangles, and that this side is parallel to this side, and therefore 8 should be over here as well. And then what about this length right here? What is the length of that side? Good, it's also 5. Okay, now we have to add 8 plus 5 plus 8 plus 5. Okay, yeah, you can add it like that too. We can also do 8 plus 8 plus 5 plus 5. We know that 5 plus 5 is 10, and that 8 plus 8 is 16. So if we add those two together, what do we get? 26. And then how do we write our answer for this? Exactly, we're just going to write units because we did not multiply. Now let's try this problem for figure H. Exactly, so we need to write our side plus our side plus our side plus our side. What is the length of our first side? 2. What's the length of our second side? 20. And what's the length of our third side? 2. Okay. And then what's the length of our last side? Or this side right here? Yep, it's also 20. Good job. All right, and now we need to add. What is 20 plus 2? All right, 22. And then what is 20 plus 2? 22 again. Now we need to add 22 plus 22. And what is that? Exactly, that's 44. So our perimeter equals 44. Good, I'm glad you said units. Units. All right, so now it's asking us that which one has the smaller perimeter? Well, which one of these has the smaller perimeter? We have a perimeter of 26 and a perimeter of 44. Exactly. Figure G is going to have the smaller perimeter. So I'm going to write figure G. All right, and then while we're at it, why don't we do one more problem? Let's do number 7. So let's look back at our directions here and figure out what we need to do first. What is going to be our first step? All right, exactly. We need to find the area of both of these figures. So we have figure M and figure N. So I'm going to write figure M. Then I have a space for figure N. All right, and so now we're going to solve for area. Do you remember the area formula? Yep, exactly. We're going to do A, or area, equals the length times the width. Now, what is the length of this shape? Exactly. We have a length of 10. And what is my width? It is also 10. Nice job. All right, so then to find the area, we are going to multiply 10 and 10. And so what do you get when you multiply 10 and 10 together? Yep, that's a big one. 100. And then how do we finish our answer? Exactly by writing square units. All right. So now that we found the area for figure M, we need to find the area of figure N. So why don't we write down our problem? The area equals length times the width. And now we are going to plug in our answers. And now we're going to plug in the sides. So let's see. For this figure, what is my length? It is 3. And what is my width? Good, it's 30. All right, and so now we need to multiply 3 and 30. Remember, if this is a little hard to see and this is a little hard to solve going side to side, let's make it vertical. So we have 30 multiplied by 3. And so now we're going to start with 3 and 0. What is 3 multiplied by 0? 0. Anytime you multiply something by 0, it is automatically going to be 0. And then we multiply 3 times 3. And 3 times 3 is 9. So our answer is 90. And then we're going to write square units because we solved by multiplying. All right, and now what is our next step? Exactly, we need to see if the two rectangles have the same area. And we write yes if they do and no if they don't. Well, let's look. So figure M has an area of 100 square units, and figure N has an area of 90 square units. Are they the same? Yes or no? No, they are not the same. So on our line, we are going to write no. And then our next part of the directions say, if they have the same area, tell which one has a smaller perimeter. So since we said no, that they do not have the same, we do not need to solve this next step. However, if you want to take that next step and get extra practice in solving for perimeter, I think that's a fantastic idea. And remember, if you solve for perimeter, you're going to have your P equals, and then you're going to add up all of the sides. And then you're just going to plug in each of the sides for the problem. All right, so this worksheet's going to give you a fantastic amount of practice problems. You're going to have another 6 problems like the ones that we just solved, and then a couple other word problems. And now just make sure when you do the writing to explain problem that you're writing using complete sentences. And that's really important just for us to know what you understand about this topic, and also it helps you to better understand how to explain your thinking. And those will be tools that you can use in the future. Alright, so now since we've had some practice with our workbook pages, I thought I'd bring us back to something familiar that we used to do in our classes. So, do you remember how we used to end our lessons with an exit ticket? Yeah, I thought they were pretty fun, and I've heard that some of you guys liked them too, so I thought I'd incorporate one in this video. So, in just a minute, I'm going to put a problem up on my board, and I want you to tell me whether or not my answer is correct. So I want you to check my answers. You're going to be the teacher this time, and I'm going to be the student. Kind of cool, right? Okay, so now I have my problem on the board, and I'm going to solve it live. So if you see something that I'm not doing, that I modeled inside the worksheet pages, I want you to call me out on it. So this is going to be a good test for you to know if I'm solving for area and perimeter right. So I'm looking for the same area but a different perimeter. Remember that. I'm just going to talk my way through the problem so that way you can better understand what I'm thinking. So, okay. So I'm going to say this is figure A and this is figure B. So for figure A, I am going to first start by finding the area, and the formula for area is a length times the width, and I know that my length is this side because I'm reaching out, and so I'm going to write A over area equals 2 times 5 because that's the width. And now I'm going to multiply 2 times 5, and that's 10. Okay, and then I need to find the area of figure B. And that is, so I have a length of 3, and I'm going to multiply by 4, because that's my width, and then I have an area of 12, because 3 times 4 is 12. Alright, so I have my area, and I have my other area. So, well, they're not the same. Okay, and so now I'm going to find my perimeter. So on my first line I'd write no, and then I'm going to find the perimeter. So So P equals, I'm going to add up all the sides. I have 2 plus a 5 plus a 2 plus a 5. And 2 plus 5 is 7, 8, 9, 10, 11, 12, 13, 14. Alright, so my perimeter for the first one is 14. Oh, square units. That's super important. I almost forgot that. Okay, and then I have to find the perimeter of the other figure. And so I have a 3 plus a 4 plus a 3 plus a 4. So let's see, 3 plus 4 is 4, 5, 6, 7. And then we're going to add 3 plus 4 is 7. Then we have 7 plus 7 is 14. Oh, square units. Alright, so now I solved my problem. Did I do something incorrect? So I know I didn't find the same area, but I did find the same perimeter. Is there something else? Do you notice it? Okay, well, I want you to call me out on it, whether it's on Zoom or in the comments. I want you to tell me what I didn't do correct. And now I will also want to give you a tiny bit of a hint that this is something I've been really emphasizing when it comes to area and perimeter. But that's the only thing I'm going to tell you. So I just want to say thank you again for tuning in to another segment on Wisdom Window. I hope you had a lot of fun learning about same area and different perimeter, and how you can also find the same perimeter in a different area. It's pretty crazy what you can do with area and to find perimeter as well. So I want you to start thinking about how you can use that in your life beyond the classroom. And then just remember, if you have any confusion or you need help with something, please let us know. We are here to help you, and we're just a email, phone call away. So just let us know. And then I also have some trivia. I have an answer from our last video and a new question. So our last question was, true or false? A camel's hump is primarily used to hold water. Did you think that that was true or false? It is false. Did you know that? That it is not primarily used to hold water? That kind of makes me want to do some research. What does the camel hump store? I don't know. That's pretty cool though. Alright, and then I have a new question for you. And that is a geography question. And it is, what ocean covers the North Pole? So what ocean covers the North Pole? Stay tuned to our next video and you will find out the answer. Alright, until then, stay happy, stay healthy, stay safe, and I will see you very soon.